Good morning everyone. I am Suguna Selvarani, Assistant Professor, Department of Mathematics, CPA College, Bodinayakanur. Today we can see about probabilities. So probability is a branch of maths that studies the patterns of chances. The idea of probability is based on observation. Probability describes what happens over many and many trials. Next, definition of probability. Probability is the measure of how likely it is some event will occur, or a number of expression the ratio of favorable cases to the whole number of cases possible. For example, the chance of a coin landing on heads is 50%. This is because a coin has two sides, so there is a 50% chance that the coin will land on heads and 50% that a coin will land on tails. Definition of experimental probability. Experimental probability is the chance of something happening based on repeated testing and observing results. It is the ratio on the number of times an event has occurred to the number of times it has been tested. For example, to find the probability of getting a 6 when rolling a dice, you need to roll the dice many times. Then divide the number of times you rolled a 6 with how many times you rolled the dice in total. This is a measure of probability. So if the event is very unlikely to occur, then the probability is 0. The occurrence of the event is just likely as it is unlikely, then the probability is 0.5, and the event is almost certain to occur, then the probability is 1. Okay, so some terms related to probability. First one is experiment. It is a situation involving chance or probability that leads to results called outcomes. Outcome. A possible result of a random experiment is called an outcome. And equally likely outcomes, if all the outcomes are with equal probability, then it is said to be an equally likely outcomes. Sample spaces. The set of outcomes of an experiment is known as a sample space. Event. If one or more outcomes is in an experiment is said to be an event. Sample point. If each element of the sample space is called a sample point. Okay, and here we can see some experiment and its sample spaces. So if we toss a coin, then the outcome will be either head or tail. If we are inspecting a part, then the outcome can be either defective or non-defective. And if we roll a die, we can have an outcome as either 1, 2, 3, 4, 5 or 6. So if we play a game, then we can either win or lose, or we can have tie. Using of simple events. The probability of an event is equal to the sum of the probability of the simple events contained in A. If the simple events in an experiment are equally likely, then you can calculate P of A is equal to NA divided by capital N, that is the number of simple events in A divided by the total number of simple events. Key points. Then P of A is equal to number of times the desired outcome occurs divided by the total number of trials. Events are independent if the outcome of one event does not influence the outcome of the other event. The events are mutually exclusive if they cannot occur together. Addition rule of the probability, that is P of A or B is equal to P of A plus P of B minus P of A intersection B. General rules of probability, that is probability is a number that always lies between 0 and 1. The sum of all the probability of all possible outcomes in a sample space must be 1. The probability that an event does not occur is 1 minus the probability that it does occur. General rules of probability, that is a probability of a sure event is 1 and the probability of an impossible event is 0. Probability of A versus B. If P of A is greater than P of B, then the event A is more likely to occur. If P of A is equal to P of B, then P of AB are equally likely to occur. Types of event. Simple event. If an event E has only one sample point in sample space, then it is called a simple or elementary event. Compound event. If an event has more than one sample point, then it is called a compound event. Mutually exclusive events. Two events are mutually exclusive events if occurrence of one of them excludes the occurrence of the other. That is, they cannot occur simultaneously. For example, let A and B be two different events. That is, A is equal to set of 1, 3, 5 and B is equal to set of 2, 4, 6. Then in this case, A and B are mutually exclusive events. That is, set of A is all odd numbers and set of B are all even numbers. So they are mutually exclusive, they cannot occur together. So A intersection B is always empty. This implies the mutually exclusive events are disjoint sets. So we can have an example. We toss a fair coin twice. Then what is the probability of observing at least one head? Okay, so when tossing the first coin, the event are head or tail. Then while tossing the second coin, so when the first coin is head, in the second coin we can have either head or tail. So if the first coin is tail, in the second coin we can have either head or tail. So the events are, first one is HH and second one is HT and third one is TH and the fourth one is TT. So the probability of all the events are 1/4 each. Okay, so here we have to calculate the observing of at least one head. So here in the fourth event, both the events are tail, so we cannot calculate that. So the probability of at least one head is equal to P of E1 plus P of E2 plus P of E3 alone. So this is equal to 1/4 plus 1/4 plus 1/4, that is equal to 3/4. Okay. Okay, and that's all about the probability. Thank you.